Greetings, the Astro 30 here, and today's kit build is this rather tiny AM FM radio receiver. It's probably not the greatest in the world. It's worth about $7 on eBay. It's not that expensive. Let's open up this bubble wrap, my favourite substance, and we'll have a look at what we've got here. So I've had this sitting around for a few weeks now. I've just never got around to doing anything with it till now because I had, well, other projects to do, like finishing that power supply. So there's the case, a set of instructions with the circuit board in the middle, and the front fascia, Panasonic, yeah, whatever. It features FM TV, now, not that we transmit TV signals around 76 megahertz on analog anymore. It's all digital now, so that's pretty pointless. And AM as well. So here's part of the case. Tiny little speaker goes here. That's the speaker. It's only about no more than an inch wide in size. And yes, it is marked positive, negative on the back there, but that is, I can think of a lot of other things bigger than that. Anyhow, that just sort of like will sit in there. Not sure how it stays in there yet. It looks like it just sort of sits in there and stays in there. But yeah, we'll cross that bridge later. Okay, we've got a bag of components here. Tiny little ferrite rod antenna. Tiny AM coil. Can't see the tuning condenser. That must be it there, or is that the... no, that's the volume knob. Can't see the condenser. This is the, well, tiny circuit board. It's pretty average. It's not really the greatest quality. It's only about 1mm thick. It uses a 2822, by the looks of things here, power amplifier IC, which once I look at the schematic and look at some data sheets and stuff, we can figure out what that is. And of course our rod antenna, which only would extend about probably, yeah, doesn't even extend any more than that. It's only about 30 centimeters long. That's pathetic for FM. Okay, this is our schematic. The IC1 here is a 9088, which is a FM receiver IC. The output is a 2822. I'm not sure who makes that, but it's just a what looks to me like a BTL amplifier, or is that going through to earth here somehow? No, it looks like BTL to me. I'll have to look up the data sheet for that. And the way they're switching between AM and FM, there's the AM FM switch there, and it's just switching the output of this IC, or if we follow this all the way up, ta-da! It's using a TA7642 or MK484 AM radio IC, which is a TRF. Okay, I now just want to pause here and bring attention to the fact that they've got three 0.1 microfarad capacitors, C28, C29 and C30 on pin 3 of IC2 at the output. Now, I'm not sure why. Now, if you look at a data sheet or even a radio schematic that uses the same IC, in this case we've got an MK484, which is the same thing, you'll see there's only one 0.1 microfarad capacitor on the output going down to earth, and one after that which goes to the base of the BC548 there. I'm not sure why they've added three capacitors in parallel there, which there is absolutely real no need for. We'll see later in the video that there seems to be an issue with the AM side of this radio. Really, technically speaking, you should be putting the output of the MK484 TA 7642, whichever, into a little transistor amplifier to boost the output, because it's not going to be very strong. You only have about 0.6 of a volt coming out of that output pin. So with that in mind, we'll just continue on with the video. Back to you, the Astro 30. So they're using a superhet, basically, chip for the FM, and which would be okay, yeah, that'd be understandable, because some of those FM stations can be very close together, so you do need good selectivity. And because AM is dying, they thought, well, we'll just use a TA642 TRF and be done with it, and don't worry too much about trying to get any selectivity out of it. It's not that overly complicated now. However, as simple as this looks, this is not the kit for a beginner, mainly because of IC1 here. As you can see, this is where IC1 goes on the back of the board. It is a surface mount device, or SMD, which can prove to be challenging to do. It's definitely not a task for a beginner, unless you want to screw the board. So in order to solder surface mount devices, you're going to need some magnification, a soldering iron with a thin tip on it, almost like a pencil tip, so you can do real fine work with it. A chisel tip is not going to work, it's just way too big. You might need some rosin flux. Rosin, incidentally, is what's already in standard solder. They're usually a rosin core solder, which is the flux, which makes the solder, the outer portion, and this is lead and tin, so the composite flow better into whatever it is you're soldering. So that's what the flux is for. You use flux on joints like this close together here because it makes the solder flow to it better, because these aren't even pre-tinned, they're just blank copper. And B, it also prevents or helps prevents bridging between the pins. So, but if you do happen to bridge between the pins, using a solder sucker probably is not the best tool to try and fix that. The first radio that I built last year, about February last year, was that super heterodyne pull AM/FM radio, and it had an SMD AM/FM chip in it, and I messed up one of the pins because I bridged it and then I put a lot of heat into it and then ended up damaging the trace, so there was actually a break in the circuit and I couldn't figure out why I was getting no output until I started doing some fault finding, and I ended up having to repair it by soldering a wire to the pin of the IC directly to somewhere else on the board where the trace went. So using one of these, or even the pencil type solder sucker, is not going to work to remove bridges. However, some solder wick will. Now the thing about solder wick is this is only 1.5 meters in length and it costs $5.95 for just that amount. So this stuff is quite expensive. So apart from the fact that I keep dropping it, you're going to have to use it sparingly. So this is only here as an emergency, that if by some chance, which is probably more than likely, that I end up bridging one of these pins together, I'll use the solder wick to debridge it rather than trying to suck the solder off with a solder sucker. I'd be a lot more successful, because with these SMD devices you've got to be really careful about the amount of dwell time you put into them, like that is how long you hold a heat or hold the heat on a pin. The average dwell time for each pin on most ICs alone is around about 3 to 6 seconds. It shouldn't be any longer than that. Any longer than that and you can run the risk of damaging the chip. As I said, this is not a kit for beginners because of that very reason. But however, what I'll be doing is I'll start off by soldering the SMD IC first, get the hardest out the way, and plus it'd be a lot easier without any other components soldered in around it. So that's the first course of action that I'll be doing with that. But let's get back to the circuit for a minute. I'm not going to bother looking up the data sheet for this because it's just a local oscillator mixer, IF amplifier, discriminator demodulator, and then an audio amplifier output, and then that just comes out and switches. It's using two inductors, one here which I reckon is the oscillator input, and here's the antenna here with another inductor, so that's the pre-selector. It's pretty basic. You can look up the data sheet to your heart's content on that. I just don't want to make this video too long going into it. The TA7642 or MK484 is just a 10 transistor TRF or tuned radio frequency amplifier basically, that's all it is. Thing is, these run on 1.8 volt max, so even if this circuit's 3 volt, that's way too much voltage for it, so you actually have to have a voltage divider in here somewhere and drop the voltage down to anywhere between 1.2 and 1.8 is fine. So we don't need to look up the data sheet of that, that's not really interesting. What I am interested in is the data sheet on the 2822. I want to see what the specifications on that is, because I can't read any, well, this Chinese hieroglyphics, so I'm not even going to bother. It's pretty easy. That's a nice feature. The door stays on there. It's just 2 AA batteries, nothing fancy, but it is small, and the circuit board does have some very almost miniaturized components to put on. So yeah, you're going to have to take your time with this. But what I'm going to do is look up the data sheet for this output IC and find out A, what it is and what its output capabilities are. It's a TDA 2822M. Apparently it's an obsolete product, so that's what it says here. So its features are supply voltage down to 1.8 volt, low crossover distortion, low quiescent current, bridge or stereo configuration. In this particular circuit, they're actually using an output socket which is wide across the left and the right inputs if you want, and they do actually say in the description of this eBay item that it is actually a stereo AM/FM radio, which is, yeah, with mono circuits, yeah, I doubt it. But it means it's got 2 separate amplifiers driving two separate earphones, so you've got a left and a right signal, but it's still mono. And by the looks of things here, the speaker is connected in bridge mode across this amplifier, but the headphones are not. So that's interesting. This is the equivalent schematic. You've got an output over there, an output over there. You've got 2 separate inputs, so it is actually a stereo amplifier. But you can operate it in bridge mode, obviously. Absolute maximum ratings, 15 volt for the supply voltage, peak current of 1 amp. Total power dissipation is 1 watt. That's, well, actually no, it can even be 1.4 watts, so that's quite a significant amount of power to put into a tiny little pissy speaker like that. They're obviously going to be a Chinese knockoff now. So what I'm going to do is I'm going to get set up here with a magnifying glass, well, my helping hand thing, soldering iron and whatnot, and get started with working on putting this IC in. And I'll go through a basic tutorial of how you can solder SMD chips using flux. So we'll do the prep work in that, and with these SMDs, take your time and don't rush it, because you're liable to make a short or something. So yeah, let's get started. Okay, this is how tiny the IC is. As we can see, compared to the size of my thumbnail, it's pretty small. So this is where a magnifying glass with some good magnification would help. Now there is a little notch marked on the board here on the overlay, print, silkscreen, whatever you want to call it, which denotes where pin 1 is on this IC. And if I turn that on, I can just see there's a dot on the bottom left of the IC here, which would locate round, well, that way. So that's how I would put it on the board. But first, obviously, I'm going to tighten my thing to stop it spinning around on me. We're going to need to apply some flux, and this stuff is not really all that friendly to your skin, so be aware of that. See, it's like an orange goop. So we take a screwdriver and we just apply a liberal amount over the pins of the pads where we're soldering to. And I'm going to do this in real time so you can actually see how long this process can take to do. So first I'm going to start by just tinning one of these pads. I might go for this very bottom one here, just a little bit of tin. And this stuff does smell when you use it, so be aware. So I haven't done anything else but zoom in, so I've got to find pin 1 again, which is down there. Place it. This is where tweezers would help, but I'm just going to do this by hand, and this thing keeps on sagging, so I need to adjust this as well. Sorry, I just had a coughing fit before. So I'll get it started in there, and then I can just sort of like heat the joint and move the IC in position, and then turn him around till it's straight, and just make sure that all the pins line up. Which it looks like from my angle they do. So I can now go ahead and just solder each pin. And as you can see, I'm not applying much heat for very long. I've got a couple of other pads soldered by accident, but that's alright. Now I might be in the way of the frame, I apologise for that, but this is kind of hard to do and film at the same time. I mean, I did bridge 2, but I just touched it again and they came unbridged, and I believe that is completely soldered now. So I tell you, flux does help. Now I'm just going to make sure that they are soldered. Looks like they are. It's hard to tell from this angle. I'm also checking for shorts. All that side looks brilliant. This side, not so much. The IC ended up a little bit further that way than it should have, but I think all bar this pin down here, pin 2, is actually soldered. And I bridged it. That'd be right. So this is where the solder wick comes in handy. I'll just place that. And there we go, that fixes that problem. I'll also unblock that hole. Done. Okay, so that all looks relatively good. And that only took me about a minute. So yeah, so now I can populate the rest of the board with the rest of the components now that I've got the IC soldered in, and don't have to worry about mucking around with that later. And yeah, go from there. It's pretty straightforward. It's just start from the smallest components like resistors and diodes and whatever or not, up to the largest parts like capacitors, leaving the output IC to last, I would suppose. But yeah, that's the IC installed. So I'll just hold this up to the camera so you can sort of like get a better look at what I've done here. See how it's all nicely soldered. I mean, it is not straight, but as long as all the pins are soldered and they're not bridged, and I'm going to double check this in a minute, you can move on. And it looks like they are. Now, rosin is sticky, so you're going to need to clean it off with some isopropyl alcohol, like I'm doing here, just to get any of the sticky residue off, because there's nothing worse than working on a board that's all sticky because of rosin. So that's okay. I've checked all the joints. They look relatively okay. There's one there a little bit, how you doing? But for what I can see, it looks like it'll work. Luckily the rest of the components are through hole. You don't have to sit here mucking around putting on even smaller components than that, like resistors and capacitors and diodes, which can be very time consuming and annoying. So yeah, now to move on to the through hole components. There is a tuning condenser, obviously, which is this. It's actually kind of tiny, and the two adjustments are there on the back there. It's only got two adjustments, so it's only like a twin capacitor job, so you can sit there and align these if you want. I'm not going to bother. What's the point? Yeah, so building this, there is no actual alignment procedure. Yeah, it is what it is. Anyway, so I'm going to move on to doing all the components, and we'll come back when I've actually done that. Okay, now we've got some progress happening here. I've got some of the resistors soldered on. Now there's two that stand up, a 4.7 ohm over here and a 1k over here. Looks like that's the only two that do stand up. And there's also the need for a link wire in between these two resistors up here. Forget that link, and you can use just one of the offcuts of the resistors to do that with. Forget that link and you'll wonder why the circuit doesn't work. And it only looks like one link. I mean, the board is pretty much laid out pretty badly. When you've actually got all the components on, don't solder the LED on till last, because you'll want to line that up with the hole in the front bezel here, so that the actual LED is sitting in the hole properly. So you do that last. And of course they give you all these really short pissy wires. Anyhow, I'm going to continue on doing resistors. I've got what looks like another 4.7 to add. One, two, well, there's three resistors that stands up. There's a 33k as well. Four, about four more resistors to go. So yeah, I'll keep going. Okay, that's all the resistors done. There's actually four that stand up. There's a 1k, a 33k, a 22k, and a 4.7 ohm. Yeah, so there's not that many resistors to do. They're just one of these tiny micro resistors, which are about 5mm long. Using a lot of Sony gear as well. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, about 12 I think. I might have missed one. 12 resistors. So I've taken about half an hour to do this. As I say, take your time. If you're good at reading these colour codes, they're only 3-band. There's no tolerance band on it, so that makes it very easy to read these. If you're good at that, that's fine. If not, just use a multimeter to verify what resistance you are putting in where. I'm going to move on now to doing the ceramic capacitors and probably the two inductors around the, wherever it's gone, the FM chip here. And yeah, come back when I've got something more. Okay, I've got all the 1 million ceramic capacitors installed. It's a tedious process. It's been about an hour. I've also got the TA7642 installed, and there's a reason for that. One of these capacitors, ceramic capacitors, when I was soldering it in here, it must have happened when I was trimming the lead or something, but it's actually busted the pad away from the trace. So in order to make sure that this has got good electrical contact, I've left the pin 1 of the TA7642 left unsoldered, because I'm just going to bend it over like that, right against the board, and I'm going to hold it down and try and flip that other end of the lead up, sort of like that, so it gives me somewhere to cut it off. And I'm going to solder pin 1 and just make it do that. So that way I know that that capacitor is soldered to pin 1 of that IC and also has electrical contact with the rest of the circuit. And that's how I'm going to fix that problem. It's just cheap copper clad. I mean, yeah, what do you expect? Okay, decisions as to what to move on to next. I might put the headphone socket in. Seems like a good enough place to start. That goes over here somehow. I can actually see what I'm doing. It helps if the earth pin wasn't bent. So yeah, I'm going to probably put that in next. Just hold him there and start one pin off. Turn him over and solder it. I mean, I must admit this is quite a fun kit to build, but you sort of have to already know what you're doing to start with. As I say, this is not really a kit for a beginner. So now there's two inductors that need to go in here. One is 7.5 turns, which I believe is this one, and the other one is 8.5. So one has an extra turn on it. So the one that's in my right hand is the 8.5 turn, and the one in my left is the 7.5. So that's what I'm going to do next. Is I'm going to put these inductors in where they go. Type of some electrolytics. This is a 220. The negative is marked with half of it with lines through it, so you know which way around these go. It's not rocket science. So there looks like to be 4 electrolytics. Next I might mount the output IC, which is the TDA2822. There's a notch on the IC here which lines up with the notch on the footprint on the board. Now I'll get into another video later of where this came from, why I've got it, and no, it wasn't from JCar. That'll become prevalent later, and I'm not really liking it because, well, the iron's sort of like how you're doing there. It's just sitting there. In actual fact, it's got some pitting on the outside of my soldering iron there. I don't know what that's from. Anyhow, so yeah, I'm not liking this band. It's just crap. It's just sliding around the desk. I have got some rubber feet which I might put on the bottom of it. Okay, I've got the AM/FM selector switch installed. Now I'm going to move on to this tuning condenser. Now it only goes in one way because if you look, it has a longer or wider tab on this side and a narrow tab on this side. And on the board there's a hole there for a wide tab, and on the very edge here is a cutout for the narrow tab. Now I've got one corner soldered. I might solder this outer tab, the large one. Now the astute viewer will notice that there is a marking AM here and AM there, and wondering what is it for? Well, it's for the loopstick antenna core. There's only 2 wires, and you just put 1 wire in either of those 2 holes, and that's where the loopstick is soldered to. Which, for all intents and purposes, I will do in just a minute, but I will actually put the volume pot on. And this also only goes one way around, you can't go wrong. They give you this mounting post bracket for the loopstick core, and it's actually got a cutout in it, so it actually slips in a cutout in the board like so, and you would just apply a little bit of glue at the bottom there to hold it, same as when you put the ferrite rod through. You pop a little glue on the ferrite rod to stop it moving around. In actual fact, before I go any further, I might just marry this up to the case and see if this ferrite rod is going to interfere anywhere. It shouldn't, but it's always good to check before gluing things in. Right, so one would assume that that's the way it goes. face down. So in order for this ferrite rod, it is kind of important because you've got two standoffs where screws go. So it is kind of important where that ferrite rod sits. So roughly where I've got it now is roughly where it needs to be. And it looks like it's the casing screws that actually hold the board in, so the board just practically sits there when the thing's apart. So I now know that where that ferrite rod is now, with about, I don't know, 4mm sticking out this end, I know that that's where I can glue him and it's not going to interfere with anything inside the case. Just to hold the speaker. And one over here, and that'll do that. Now you do have this thing, which is the dial indicator. Now I've got to work out, because this has got to go in a strange angle inside here. What I really should do is put the LED in and actually get that lined up with the front panel, screw it to the condenser. Now as this rotates, it's going to wind up this plastic indicator. So that's why we put it fully anti-clockwise first, so that one, you can get it in there, and two, it's actually winding up the correct way. Otherwise you're going to have to take it apart and do it again. So I put this screw now in the on-off switch, volume control. Okay, after mucking about for a while, there's a positive marking on the board, which is the positive battery lead. So we throw the wire on the floor. So we do actually wire the positive side to here. I've got a speaker connection here and a speaker connection over here. Now that's the ground, so it looks like the speaker is connected across the switch, not the ground. So it would be connected across, most likely, this pin here, where the S is closest to. I could be wrong, but that's where I'm going to solder it, and then I'm going to test it before I hook up the FM antenna. Okay, let's turn that on. Got a light. We do have output. AM doesn't appear to be working. Okay, so it powers on, but the AM side's not working. It's kind of disappointing. But that red wire for the positive is in the way. So what I might do is I might take that out and actually tin the side of the connector, and actually just move that to the side of it. Yeah, that'll probably work a bit better. Now, one, I've got to fault find why the AM's not working. Two, this tuning capacitor is not sitting in its place correctly. So yeah, I'm not sure what's going on here with the AM, but I need to connect up an FM antenna, which goes over there. So I need to put that in there somehow. It's supposed to slide in. There we go. Yeah, and you put the screw through the back. Until it's tight. There we go. Yep, that's working. Now, I reckon I can just solder straight to that. Well, FM works, but I can't get AM to work. If I touch where the AM antenna comes in, the loop stick, I do actually get A channel, but it's not doing much. Now, I'm trying to adjust the capacitor. It doesn't work. I have no idea why it doesn't work, but it's not working. And this stupid scale thing is jamming up every time you turn it. But I actually reckon I've probably got a dud TA46, whatever the hell it is. TA7642, I believe is, I've got a dud one. FM is working to a point, but its tuning range is crap. So I have no idea where that's pointing at the moment. So I'm going to have to do a little bit of investigation here, probably change that TA7642. I am getting 0.6 of a volt at pin 3, which is the voltage input. It's kind of starting to annoy me. This thing is a piece of shit, to be honest. Well, I did get it to work, but I had to add a wire as an antenna to pin 2 of the IC to get it to work a little bit better. But it should work better than that. That's bad. So this kit is, yeah, it's crap. Absolute crap. It's not even worth the $7 odd you pay for the damn thing. So really, realistically, I shouldn't have bothered. I mean, FM works, but yeah, this thing is junk. I honestly wouldn't bother buying it because you'll be pretty much disappointed with its results. And this bloody circuit board and this bloody lead keeps popping out of the hole, and it's starting to piss me off. It won't stay there. You've got to wind this bastard down in so it sits flush. So then you have to ass around putting the casing on. So yeah, I tried another IC, made no difference, so I'm just going to leave it as it is because I can't be bothered messing around with it anymore. So now we've got 2 longish screws, 3 longish screws, so I am assuming that they go one there Yep, so that's together. Antenna sort of sits there like that. And we need to deal with the front fascia panel, which looks like it's just double-sided glued on. So I'll remove the backing tape, push it home, and there we go. The tuning is very stiff, but that's what you get. Now I need to find out what I did with those batteries. FM's working alright. Yeah, good luck trying to tune that piece of shit. Okay, that's it. I'm not happy with how this kit works. AM doesn't work at all. Barely. That's that. This is a waste of time. Anyway, I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe below. And you can always follow me on Facebook and Twitter. The links are in the description as usual. So anyway, this is the Astro 30 saying I've had enough of doing this. This is just gonna go in the bin. See you later.